Hello friends, welcome to Joy of Life. So we are going to do a medium level problem again. The problem number is 144, binary tree pre-order traversal. So previously I've done a video on the in-order traversal, and now we are doing a pre-order, and the next would be a post-order, right? And we have already done a lot of videos on the in-order traversal as well. So do check them out. I'll leave links in the description for all the traversal algorithms, right? So given the root of a binary tree, return the pre-order traversal of its nodes values, right? And of course, I think they have also recommended us that do it iteratively and not use the call stack. So what happens in a pre-order is print the we first process the root, and then we go to the left, and then we go to the right. It's a pre-order, so pre means that we are going to pre-process before we go to the left or the right. So if you see the results over here as well, that we first printed 1 and then tried going its left, and then there was nothing, we came to 2, then we printed 2 and then went to its left, and then we printed 3 and tried going to its left, and there was no left and we could not proceed, and we have the answer 1 2 3. We are quickly going to move over to the board and check out the solution, right? Once again, I have taken the same tree, and we first visit the node, so 1 will be printed. So again, if we take a call stack over here, so let us take those same variables that we have used previously. So we have a current, and current always starts with the root of the tree. So 1 is there with me. So what I'm going to do is first print 1, right? And then I will try going to its left and then to its right. So I will now, since I'm done printing 1, I'm going to go to the left, right? This is what we are doing. So 1 will go to the call stack over here, and 2 will come into picture. So the moment 2 is called, this in the same function, we are going to print 2, and then 2 is going to get pushed inside the stack, and 4 is going to get called, right? So what happens over here, 2 is sitting in this call stack, so 4, immediately we print the 4, and what we do is we try going its left, nothing, we try going its right, again nothing. So 4 is gone from here, and 2 is popped out, and 2 came back over here. So from 2, what we have done was we are done with these two statement, and this is the reason why it has gone to the stack. Now it will go to its right, so 2 will be back to the stack again, and 5 will get called. So in 5, what we do first is we first print its value, right? And then we try to go left, right. Okay, nothing is there. So 2 is going to come back again. So 2 is back again, and we see that, okay, 2 was done. It was the last line for which it went to the call stack. So 2 is going to pop out again, and 1 is going to pop back out from the stack, right? So we saw that, okay, 1 has printed, it has done its left. Now it will call its right. So 3 will come into picture over here. And what will happen is 1 will go inside the call stack, right? And 3 will first print itself, and it will then try to go left. There is nothing to the left. It will try to go to its right. So 6 will come here, and 3 gets pushed inside, right? So 6, what it does, it's immediately it goes ahead and print itself, and it tries to goes left and right. There is nothing, so he cannot proceed further. So what happens is 6 is done. So 3 is going to get popped out from the stack. So 3 comes here, and we see that, okay, we are at the last line of 3. So 3 is also done. So 1 gets popped out again, and we see that, okay, there is nothing to be done for 1 as well. So 1 is also popped, and 1 is gone. So what we are left over here is the result, that is the pre-order traversal. So this is again a very straightforward solution if we do it recursively, and even if we don't do it recursively, it's also going to be a very simple solution, and we are going to use simulate the stack, and we are going to get this done. So we'll move over to the code and quickly check out the solution. So once again, what we need to return back at the end of this processing is a list of integer, which we'll call result, and let this be a array list once again. And if we see that we are passed with a null root, then we are immediately going to return the result. That's an empty array list, or we are going to return the result at the end as well, right? And what we have seen so far is a stack wherein we have been stacking things, and we are going to store a tree node inside it, and let's call it stack, right? So what we are going to do is first we are going to this time put the head of the tree inside the stack, and we are going to iterate until the stack is not empty, because we are continuously going to push things, right? So what we'll do is we'll get the nodes out one by one, and let's say we get them out in an element, and we'll do a stack dot pop. we have the root initially, right? So first thing that we should do is we'll add it to the result. So now what we are going to do is we are going to add the left child and the right child. So what a pre-order say is that you have the left, you have the root, then the left, then the right, right? So what we are going to do is we are going to check the childs over here. Then we are going to add them to the stack. And same thing we are going to do over here, right? Is it going to work? No, it's not. Because when we take things out from the stack, it's going to come out in a reverse order. So right should go first and then the left. So yeah, I just wanted to show you that how important that part is, because we have to keep in mind that in stack, it comes out in a reverse order. So let's run this code and check. Yep, it has been accepted. Let's do a submit and check for a wider range of test cases. Yep, we are good. So yeah, you got the trick, right? So always keep in mind that for a stack, you have to reverse the order. Otherwise, the values that you might get might not be accurate. It's going to change the order. So I hope you got the solution. You understand the concept of how call stack is working and how we are mapping that to our normal stack over here. So when it is said iteratively, we are just going to simulate what call stack does for us and nothing else. So do let me know what you think about the solution. Do give it a like if you think this solution was helpful to you, and yeah, do share and subscribe with your friends as well. And that's it from this video. We're going to meet soon again. Bye bye.